All right, how's everyone doing out there? Hopefully, you're getting some of this work done. We've seen that a lot of people have been submitting their quizzes from last week. If you didn't get those in yet, make sure you get them in. This week, we're going to ask that you go through lessons 3, 4, 5, and 6, and then you'll be taking a quiz on Friday for those 4 lessons there. Right, and the quiz again will be made up of the multiple choice questions that we have, and maybe some of the short answer if you can input them easily. All right, so first we're looking at lesson 3. Lesson 3 has to do with polynomials. So quick definitions that they start off with. Whenever you see the word polynomial, it is just an algebraic expression with one or more terms. So again, a term is any time that we have just a number like 8, or even a number with a variable like 8y, or even a variable by itself. So if we just had something like x squared, that would be a term there. Then we have 2 kind of special types of polynomials. So a monomial, if we take a look at monomial, it starts with mon here, which is going to be 1. So it's a polynomial with 1 term. And binomial, again, binomial starts with the prefix bi here, which is going to mean 2. So it is a polynomial with 2 terms. Another one that we will come in contact with is also a trinomial. So if you take a look here, a trinomial is going to be any polynomial and then tri that has 3 terms. So we have 3 terms. And we'll be dealing with those a lot. A lot of our answers are going to be trinomials when we're going through here. But it's just another special type of polynomial that you should know the name of. So keep reading here. It says a polynomial expression is a monomial or the sum or difference of more than one monomial expression. So to add polynomials, we simply combine like terms and see how it works in this example here. So they're adding the 2 polynomials. The first one is in our parentheses here is x squared minus 9x plus 3. Then they're adding the second polynomial, which is in our second set of parentheses, which is 2x squared plus x minus 4. So when we're combining like terms, we need to identify our like terms. So a like term is anything that has the same variable to the same exponent, or if it's just a number without a variable, that is a like term with other numbers that are just constants without variables. So first I'm going to go through and highlight all of the terms that have a squared. So if we look here, we have x squared and 2x squared. Then we can take a look at just the x's. So negative 9x plus positive x there. And then finally our terms with just our constants here, plus 3 and minus 4. So the way that they got this answer here is they started by adding our terms that we highlighted in yellow, the squared terms here. So x squared plus 2x squared. Right? If there's not a 1 written in front, you can write that 1 in there. 1x squared plus 2x squared equals 3x squared. So that's where our 3x squared comes from. Then we have negative 9x plus 1x. So negative 9x plus 1x is going to be negative 8x. And then finally, positive 3 plus negative 4 gives us negative 1. So they went and did it kind of horizontally in that area there. What we did in class was a little bit different. So I'm going to show you just to refresh your memory about how we did this in class. So in class, when we were adding polynomials, we'd write it out. So x squared minus 9x plus 3. And then below it, we would write the second one. So I know you can't see it here, but you'll see it in 1 second. Plus 2x squared plus x minus 4. So something that looked like this. And then we said draw our line, and then the CLT line, or combine like terms. And then we can go vertically here. So again, we have 1x squared plus 2x squared. We have 3x squared. Then negative 9 plus 1x is going to be negative 8x. And then finally, again, positive 3 minus 4, negative 1. So in class, remember we drew our line. We first lined up all the terms that were like, so right, we lined up our squareds underneath each other, the terms with just the x's, and then our constants, and then just kind of added straight down there. So some of you might remember that stuff there. If we take a look, the next part here has to do with subtracting polynomials. So to subtract polynomials, we change the sign of each term in the second polynomial and then add them here. So if you take a look here, we still have our polynomial in the first one here. It's 2x to the third power, or 2x cubed, plus 4x squared minus 6x. And then we're subtracting this whole second polynomial. So we're subtracting 4x cubed minus 3x squared plus 5x. So our first step here is to keep the first polynomial the same. Then we change the sign from subtraction to addition here. But then we have to change the sign of each term. So instead of positive 4x, what we're doing is we're saying we're going to add the opposite of that, which is negative 4x cubed. Then instead of minus 3x squared, we're going to add 3x squared. Instead of adding 5x, we're going to add the opposite, which is negative 5x. So again, what we're doing is changing our subtraction and then changing each term to its opposite, because if you look over here, subtracting is adding the opposite. So once we have it written like this, what we can do is then what we did before, where we combine our like terms. So if I write it over on the side here, let's see. We have 2x to the third plus 4x squared minus 6x. I can move that over a little bit. Minus 6x. And then, since we changed it to addition, right, we're going to be adding to it. Then we put in our opposite numbers here. So negative 4x to the third matches up with the x to the third above it because they have the same exponent, so we can combine them. Then we keep going here, plus 3x squared. Again, these are like terms because they have the same exponent. And then finally, negative 5x. Go through and collect our like terms, our CLT line, and then we go through here. So 2x squared minus 4x cubed, or sorry, 2x cubed minus 4x cubed. We do 2 minus 4, which is negative 2, and our variable stays the same. Then 4x squared plus 3x squared. We just add the 4 and the 3, plus 7, and our variables stay the same. Then finally, negative 6 plus a negative 5. Right, so we add the numbers and keep the sign, and that's going to be negative 11x. So when you're going through and you're combining these like terms, it's also very important here to make sure that you're double checking your answers with your calculators when we're dealing with negative numbers. A lot of times we make little mistakes there, but that will completely change your answer. So our final answer here is negative 2x to the third plus 7x squared minus 11x. We can't combine any of these terms here because our variables all are to different powers here. So we're done with that one there. Now, gave us 2 sample questions to take a look at. So this first one here says, what is 4x squared minus x squared plus 2? So if we're going through here, this one again is subtracting of a polynomial. So our first step is always to change subtraction to addition, and then change each of the terms to their opposite. So plus negative x squared plus negative 2 there. Then we can go through it, and I'll write it up here. And I would line them up horizontally, or you can go through and do it, vertically, or you can go through and do it horizontally, but this is the way we did it in class. So we would write 4x squared minus 6, and then underneath it, our terms here, negative x squared, right? And then we have negative 2. And then we're adding these up, right? So we're combining our like terms. So 4x squared plus negative 1x squared here will be 3x squared. And then our negative 6 plus negative 2 is going to be negative 8 there. So if we take a look, that one's choice A. We did it correctly. Yay. I mean, the biggest mistake people are going to make here is if you do not change this to addition and add the opposites. Often we'll forget that this is actually negative 6 minus 2, right, like we have here, and students will often give us a choice, give us an answer that looks something similar to one of these ones here, like negative 4. All right, taking a look at sample 2. Sample 2 again. Same types of problems here, except for if it's addition, we don't have to change anything there. So now we just have to line up our like terms. So over here we have 6x squared plus 4y squared. Then we're looking at our second polynomial, the like terms, so the 5x squared we'll write underneath our other x squared. And then the y squared minus 3y squared goes on this side. We combine our like terms. 6x squared plus 5x squared is 11x squared. And 4, positive 4, minus 3 is going to be plus 1y squared. If you take a look here, we don't necessarily see the answer in the same form I had written it, but if we take a look at choice C, right, we have the same 11x squared plus, and then they have y squared written without the coefficient 1, which is the same as what we did up here. All right, so then let's move on. So from here, we're going to take a look at multiplying polynomials. And we'll first take a look at what they did, and then we'll go through and I'll show you kind of how we did the same type of problem in class. So to multiply polynomial expressions, you multiply each term in the first polynomial by each term in the second polynomial. Then you combine like terms if needed. To simplify the resulting polynomial expression, for example, we have this one here. So now the big difference here, right, is we have two binomials, so 4x plus 3 and x minus 2, but we don't have any addition or subtraction in between them here. So when the parentheses are written right up next to each other, we're multiplying. So the way that they do it here is they take the first polynomial, right? So they take 4x plus 3 and they multiply it times x minus 2, starting with just the 4x times the x minus 2. And then they take the plus 3 and they multiply plus 3 times x minus 2. And I'll go through and kind of highlight our x minus 2 there. So they broke it up this way here. Then they go through and they use the distributive property, right, to do 4 times x, which is 4x squared, then 4 times negative 2, right, so if we go here and here to get negative 8x, bring down our plus, they have 3 multiplied by x is 3x, and then 3 multiplied by negative 2 is negative 6. Then they go through and collected their like terms here, so negative 8x plus 3x is negative 5x. The other terms were just brought down and they've got their final answer there. So in class, we did it a little bit differently. So I'll show you what we got here. So if we take a look, we had that same problem. So 4x plus 3, then in parentheses, x minus 2. And we went through and drew our lines just from this part here. So this was the saying when you were talking in class and you hear Superman saves everyone, right? So we could take 4x multiplied by x, and we'd get 4x squared. Then 4x times negative 2, and we'd get negative 8x. Then we'd switch it up and take a look at 3 and go underneath here. So 3x times, or 3 times x, right, is going to be a positive 3x. And then 3 times negative 2 is negative 6. Then we went through and just went down again, and we collected our like terms. So nothing matches up with the x squareds there, so we have 4x squared, negative 8x plus 3x, negative 5x, and then negative 6. Nothing to combine there, so just negative 6. So both ways are absolutely fine. They get you the same answer. Just wanted to remind you about the one that we did in class here. All right, so these questions get a little bit more difficult when they put them into a word problem, like the word problem here, but it's just about setting it up correctly. So this problem here, sample 3, says the length of a rectangle is 5x plus 1 units long. The width of a rectangle is 2x plus 5 units long. What is the area in square units of this rectangle? So in this problem here, right, they want us to find the area in square units. Really? I mean, they're just asking us to do what we just did in the problem above, but with two different binomials. So the first binomial we take a look at here is the length, which is 5x plus 1. And then the second binomial is the width, which is 2x plus 5. And we're going to plug that into our area formula. So we have area of a rectangle equals length times width. And we plug in each of those there. So we have area equals, on this side we have 5x plus 1 multiplied by 2x plus 5. So once we set it up like this, we just simplify it like we did up there in the problem before. So I'm going to slide this up a little bit. Starting with our 5x, we're going to distribute it to both terms here in our second binomial. So we'll do 5x times 2x, which is going to be 10x squared. Then we multiply 5x times 5, which is plus 25x. Then we'll do a different color for our second term here. So we're going to take 1 now and multiply it by both terms in that second polynomial. So we have 1 times 2x, which is plus 2x. And then 1 times 5, which is going to be plus 5. And then this is where we still are going to now combine our like terms. So we draw our line for our CLT. And we just add down. So 10x squared has no like terms to combine, so we just write 10x squared. Over here, 25x and 2x here, we add those together, plus 27x. And then our 5 again has no like term to add up here, so we just put plus 5. And this is all equal to our area. So we take a look, which of these choices matches. Oops, sorry. So if I'm looking for 10x squared, plus 27x plus 5, then I'm looking at choice D here. So that's multiplying polynomials. So this is review of stuff that we did do towards the beginning of the year. And when we take a look at the problems in the problem set, most of them are pretty explicit, right? So our first one, you're just adding like we did in the first example. Then if we keep going through here, the second one, right, is distributing, right? So we're just multiplying this polynomial 5y, or this monomial 5y squared to each of these terms here. Finding the difference. Remember, the key to finding the difference is we keep our first polynomial the same, we change subtraction to addition, and then we go through and change each of these to the opposite sign. So if it's positive, it becomes negative, then becomes positive, and then we combine like terms like we did when we added. The only different one here is choice 4. So choice 4, or question 4, sorry, is we're taking a look at multiplication, but here we have 3 terms in our second polynomial. All that means is we do one more thing of multiplication here. So you'll have 5x times x squared, 5x times negative x, and then 5x times negative 4. Right? So you just have one extra multiplication problem when you multiply here. Finally, taking a look at the word problems. Not too bad. The first one has to do with finding area. So again, remember that area equals, so this is a square, so you could say it is just the side times side, but always length times width. For dealing with any rectangle or square, we could start it with this way here, and substituting in each of these terms into your area formula. And then taking a look at the other questions here. On the top here, perimeter. Remember that if this is the perimeter, so the perimeter is 19z minus 7, you need to represent the length of the remaining side. Well, to find this 19z minus 7, we had to add up all 3 sides. So if we're trying to find this missing side here, we can use the opposite of addition and subtract there to kind of find that missing side that goes in there. All right, so do your best. Remember to put your answers up online in the quiz once we get it posted. And if you have questions before you're taking the quiz, last quiz I did put up 2 attempts on it. If you have questions and you get some things wrong, make sure to send us a message. We can go through and give you a little bit more explanation, or send you to a resource where you can find some of this information that might be helpful for you. All right, and remember also to take a look at the Regents questions that Mr. Smith is posting in those videos there. The more practice you get, the better. All right, everyone, do a good job. Keep working hard.